All right, welcome back. So we've got another Laplace transform problem to do. This is actually going to be number 4 if you have the textbook and are following along. And we're going to solve by Laplace transforms. You can't read my cursive. Don't worry, there's nothing really, it's not that important in this one, okay? And it's going to be y double prime plus 6y prime plus 5y equals 12 e to the t. Now, if you're really sort of with it, you'll know you're like, oh, I could solve that. I don't need Laplace transform. And you don't. You don't. You could solve this. It's going to be an undetermined coefficients or variation of parameters. Pretty easy. The only thing is you're going to have like a t e to the t because this thing, right, its characteristic solutions are going to be e to the negative 5t and e to the negative. No, you don't even need that. So you could solve it pretty easily by undetermined coefficients, but we're getting used to practicing this method, okay? Oh, I do need initial conditions. Y of 0 is -1. Y prime of 0 is 7. Okay? So now let's go ahead and take the Laplace transform of the things we need. So, let's call the Laplace transform of y. I'm going to again use a cursive y for that. Laplace transform of y prime. Remember that's s cursive y minus y of 0. In this case, since y of 0 is -1, it's going to be s y plus 1. Let me highlight these. Okay. L of y double prime. That's s squared y minus s y of 0 minus y prime of 0. And that's going to be, that's s squared y minus, now y of 0 is -1, so it's going to be plus s minus 7. Okay, now we can go ahead, let's put this through our Laplace transform machine. So our original equation up here, oh, I need the Laplace transform of 12e to the t as well. Let me write that over here. So Laplace transform of 12e to the t. I could do the integration, or I could just look here on my chart. Oh, here I've got a e to the t. E to the at is 1 over s minus a. Okay, that's the one I'm going to use. So we've got 12e to the t, so it's going to be 12 over s minus 1. Okay. All right. So now our differential equation becomes s squared y plus s minus 7, that's our y double prime, plus 6 y prime sy plus 1 plus 5 y equals 12 over s minus 1. Okay, now I'm going to go ahead and try to get y by itself. So y times s squared plus 6s plus 5. Now I still on this side have plus s minus 1 equals 12 over s minus 1. Okay, so this plus s came here. This negative 7 and this 6 got together to join and become negative 1. Okay? Bad joke came through my mind. Oh, they joined together to become 1, but then became negative 1. That means they, never mind. Okay, so y equals, well, let's actually first put everything on the other side. So it's y times s squared plus 6s plus 5 equals 12 over s minus 1 plus 1 minus s. Okay. Now, one thing I want to notice before we move forward. The original equation was y double prime plus 6y prime plus 5y. And we have the characteristic polynomial for that on this side, which is what we're expecting, right? We expect to have that come up. Okay? Now, to do this algebra, what I'm going to do first is I'm actually going to join these two terms together. I normally wouldn't do that, but because of what we're going to be doing, and I'm going to factor this too. So I'm going to write this as y times, this is s plus 5, s plus 1 equals 12 plus, now this is going to be 1 minus s, s minus 1 over s minus 1. Okay. So y times s plus 5, s plus 1 equals, now here, I'm going to play around with this a little bit. This is 12. And now, if I just change the sign, okay, and this is negative, then I'm going to get s minus 1 squared, right? Okay, so I'm going to write this as minus, and then s minus 1 squared is s squared minus 2s plus 1. Okay, so y is now going to equal, let me write this as negative s squared plus 2s plus 11 over s minus 1, s plus 5, s plus 1. Oh, how much space do we have? Oh, we're good. Make it a little smaller. Or actually move it up a little bit. Okay. Oh, all right. Now, what are we going to do next? Well, oh, that's right. We have to do a partial fraction decomposition on this, right? So let's do that. So the next sort of piece of this is we're going to do a partial fraction decomposition. Okay, so let me copy this. Okay, so I'm going to write this instead. I'm going to write this with a negative in front. And that would change all the signs here. So if I do negative, that becomes negative, that becomes negative. Okay. You know what? No, I'm just going to leave it as it was. Okay, I'm going to say that this equals sum A over S minus 1 plus sum B over S plus 5 plus sum C over S plus 1. Now, don't leave me, okay? Because I know that you've all seen partial fraction decomposition before, and you're like, oh, I know it, I hate it. But I have a trick for doing this quick, okay? So I have a trick. Maybe you've seen it before, maybe you haven't, but I'm going to go ahead and do it now. So this means that I'm going to have negative s squared plus 2s plus 11. This part you've all seen before. This is not anything you haven't seen. Okay, so I'm just writing out the numerators. Okay, and then the first thing, what I'm going to do is I'm actually going to pick special values of s that are going to give me some of the constants quick. Okay, so for example, if I pick s equals 1, okay, then this is going to be 0 and this is going to be 0. So s equals 1, my left-hand side is going to be what? Negative 1 plus 2 is 1, plus 11 is 12. Okay, so if s equals 1, I get 12 equals, and on the right-hand side, this is 0, this is 0, and what do I get? I get 6 times 2, 12. So I get 12a equals 12. Boom, I have a equals 1. Okay. Let's pick s equals, now the next one I'm going to pick, let's pick negative 1. Okay, how am I picking these? I'm picking these to make these things go away. Okay, so if s equals negative 1, this is 0 and this is 0. And I get what on the left-hand side? 1 minus 2 is negative 1 plus 11 is 10. Just make sure of that. Something feels off. Negative 1 minus 2, negative 3 plus 11 is 8. I knew it was wrong. That's why I have the thing beside me. So I have 8. And then on the right-hand side, okay, the A and the B go away, and I'm left with what? Negative 1, so this is negative 2 times 4, so negative 8c. So c equals negative 1. Okay, finally, let's pick s equals negative 5. I'm picking it to make this and this go away. All right. So if s equals negative 5, on the right-hand side, I'm going to get 24. Let me just check that. So negative 25 minus 10 is negative 35, plus 11, negative 24. Right-hand side, remember negative 5, so 0, 0, and I'm going to get what? Negative 6 times negative 4, so negative 24b. So b equals 1. Okay, I'm just checking, make sure that I'm getting the right thing that I got yesterday when I did this problem. Let me now make things a little smaller so we can fit this all on one nice page. What am I doing? Okay, that ought to fit. Okay, so our equation now. So what do we get? Our y equals 1 over s minus 1 plus 1 over s plus 5, okay, minus 1 over s plus 1, okay? And we remember the Laplace transform we're going to use is that the Laplace transform of e to the, I think it was at, equals 1 over s minus a. I think that's it. Let me just check. Yep, right here. Laplace transform of e to the at is 1 over s minus a. Okay, so that means taking this through the inverse Laplace transform, our y of t equals e to the t plus e to the negative 5t minus e to the negative t. Okay. All right. I'll see you all in the next video.